This is the beginning of video 6 for section 5.3. We'll start things on number 28. Same instructions as before. Find the average value and where the function has that value. So we'll start this one. We'll actually look at the graph. Squeeze it in right over here. We have a parabola that has been shifted over. If you remember your translation rules, it's moved over 1 in the positive direction. And it's a regular parabola from there. So our parabola is going to look like this. We're looking at from 0 to 3, which is over here someplace, out of scale. So this section is going to be bigger than this section, but none of it's negative, not that that would matter. Okay, so now let's first find the net area, which in this case would be the same as the total area, which is completely unrelated to this question. And we notice this is the first one we've seen like this. And in general, we're going to have a lot of trouble with embedded functions for integrals. And if you think about how complicated derivatives get with chain rules, then you can imagine trying to work backwards from something that's very complicated and rework it, out of a product rule or a chain rule back to its normal function. But I think we're going to be okay on this one, and let's make a guess what we think it's going to be, and then we can check it. So the antiderivative, I'm going to try saying it's 1/2 x minus 1/3, I should say, x minus 1 cubed. All right, and if this doesn't work, we can always back up and just multiply this out as a polynomial and do it that way. So let's check to see if this is right. The 3 comes down and cancels out, and there's nothing in front, which we don't have anything. We don't touch the inside, and this goes down to a 2. And then here's where we'd have a problem if this was anything other than x, an x in here. Because then we got to do the chain rule, but the derivative of the inside is just 1, which gives us exactly what we started with. So if this had been like an x squared minus 1, we would have been out of luck. With experience and practice, we'll learn that pretty quickly. But we're good here. So 0 to 3. So we've got 1/3 of 3 minus 1 cubed minus, now be careful, because if I plug in 0, a lot of the problems we've been doing, the output is 0, so we've just been ignoring it. But in this case, when I plug in 0, I don't get 0. I get 1/3. 0 minus 1, I get negative 1 cubed. So I get 1/3 of, let's say, 2 cubed, so that's 8, minus, but it'll turn into plus, 1/3. So I get 8/3 plus 1/3 is 9/3. Looks like the net area is 3. But I don't want the net area, I want the average area. Or the average height, excuse me. So I take my area, and then I divide it by the width, which in this case is going to be 1 over, well, the width is going to be 3. So I multiply by 1/3. And now I get an average value of 1. So now the question is, where does the function actually have that height of 1? And so now I just take my function and I set it equal to 1. And then I'm going to solve this. So it looks like the easiest way would be just take the square root, which gives me positive and negative 1 equals x minus 1. Move the 1 over, and I get an answer of 1 plus 1, so I get x equals 2, and 1 minus 1, which is 0. So these are the two places. So my average height of 1, so it happens here, and then it happens right over here at 2. Okay. That's what we got. So then number 29, it's pretty much the same question, except it doesn't ask us to find that c value. So it just wants the average value. But the difference here is it doesn't want us to use the integral. It doesn't want us to do the integration to find the answer. It wants us to do the same, find the same outcome. So in other words, what have we been doing? We've been finding the net area, and then we've been dividing it by how wide it is. So to answer this question, we got to find the net area, which in this case would be the same as the total area because it's above the axis. But that's just going to be 1/2 height and base, which is going to be 1/2. The height is 3. The base is 6. So I get an answer of 9. So that's the net area, but I want the average height, so I'm going to take that, and then I'm going to multiply it by 1 over the width of the interval, which is 6. So I get 9/6, or 3/2. So that's it. Number 30 is going to be the same question. A little bit more complicated this time because of the shape. Here is that equation we've been talking about. This is the semicircle. So that sketched would be a semicircle from 1 to -1. The negative, we know, flips the function over. So now we've got the bottom half of it, and then the +1 on the outside moves it up, and we end up right here. So I know that this section right here is just half of a circle. But that's not the part I want. I want this part that's underneath it, because that's what the height of the function is. It's right here. So I need to find this amount. And so what I see is a rectangle minus a semicircle. So the area of the rectangle is going to be 2 by 1. So the area is 2, minus the area of the semicircle, going to be 1/2 of pi r squared. The radius is 1, so that's going to be 2 minus 1/2 of pi 1 squared, which is just 1. And so this right here is my net area. All right. Rectangle 2 by 1, semicircle, pi r squared, radius of 1. 1 squared is 1, 1/2 pi looks good. So that's just the net area. They want the average. So I'm going to have to take the net area and then divide it by the width of the interval, which is 2. So that's going to give me an answer of, it's the same as just multiplying these by 1/2. So 2 times 1/2 is 1, and then 1/2 times 1/2 is 1/4. And there's my answer. 31 wants me to do the same thing. This time they didn't provide a picture, but we should all know what sine looks like. And we should also, even before I get done drawing the picture, realize that from 0 to 2 pi, the net area is going to be 0, because that and this are going to cancel out. So that simply means that the net area is 0, and 0 divided by the width of 2 pi is still going to be 0. Okay, and we got a couple left. Alright, number 40. If you haven't read it, you might want to pause the video and spend a little time thinking about this. So the driver averaged 30 miles per hour on a 150-mile trip. And then he returned over the same 150 miles at a rate of 50 miles per hour. He figured that his average speed was 40 miles per hour in the entire trip. A, what is the total distance he traveled? So he went 150 miles there, and then he went 150 miles back. So it sounds like he went 300 total miles. Part B, how long did it take? Well, we went 150 miles and we averaged 30 miles per hour. We went 30 miles per hour. And so 150 divided by 30, that'd give me 5 hours. And then on the way home, he went faster, and that then would have taken him 3 hours. And so he went, or it took him 8 hours. Part C, what's the average speed for his trip? And then part D is what's wrong with the driver's reasoning where he thought it was 40. So let's do part D first. The driver, it would appear, took a speed of 30 miles per hour and a speed of 50 miles per hour, added them together and divided by 2, and that gave me 40 miles per hour. Okay, so what's wrong with that? Well, what's wrong with that is the 30 and the 50. The best way of saying this is we went 30 miles per hour for longer than we went 150 miles, or longer than we went 50 miles per hour. Think about it this way. If you get in your car and for 1 minute drive 5 miles per hour, and then for an hour drive 100 miles per hour, your average wouldn't just be adding the two together and dividing by 2. You need to account for how far you went and how long it took you. So what we need to realize is that the parts A and B on this question are leading us to the answer. And we could also think about it as the average speed for the trip would be defined as, how far did you travel? And then divide that by how long it took. And so we went 300 miles and it took us 8 hours. And so that would be whatever that is. Let's see, 150 fourths, which is 75 halves. So what is that? 2 goes into 75, so what, 37.5 miles per hour? Did that fast, don't want to check my work, so hopefully that's right. Now, had he gone, an average of 30 miles per hour there and 30 miles per hour back, then your average would have been 30. But the reason it's, 37.5 is, again, he went 30 miles per hour and it took him, he was traveling that speed for 5 hours. And then he was only going 50 miles per hour for 3 hours. So of his 8-hour trip, less than half of it was going at the faster speed. So it's not just a direct addition of those two speeds. Hopefully that makes sense. And if not, just go back to the definition on part C here of average speed, and it should make some sense. So 41 I think is going to be along the same lines. We released 1,000 cubic meters of water at a rate of 10 cubic meters per minute. Then we released another 1,000 at 20 cubic meters. So the question then says, what's the average rate at which the water was released? So the answer is not going to be 15. Okay, the answer isn't going to be what he did on part D, which is, well, I released it at 10 for a while, and then I released it at 20 for a while, and those are the only two I released. So I add them up and divide by 2, and that gives me 15. That is incorrect thinking. Now, what would be the math we need to do? The average rate at which the water was released is going to be answered by how much was released. So what's the total amount released? And then how long did it take? So how much was released is nice and easy because we released 1,000 and we released another 1,000. So we've got 2,000 cubic meters. And now how long did it take? Well, we released 10 cubic meters per minute, We released the first 1,000 that way. So how many minutes did that take? 10 is going to go into that, 100 minutes. So it took us 100 minutes to drain it, or to release that much. But then we did it another 1,000 at a little bit faster. So that's going to take, it's twice as fast, so it's going to take half as long to do it. And so just do 1,000 divided by 20, and you get 100 divided by 2, you get 50. So the average is actually going to be whatever 2,000, the total amount we released, divided by 150, the total time it took. So let's see, zeros cross out, 5 goes into both, 5 goes into 20 40 times, 15 3 times. So the average is going to be, let's see, 13 1/3. Meters cubed per minute. That would be my average. Okay, that ends this section. If you have questions, please make sure you follow them up in class.